Hi guys, sorry I can't be with you today. I'm technically in the building, just not with you, learning how to use the new Power School that's updated. Anyway, take a few minutes and try the warm-up on your own, and then I'll go over answers, but you can also check with your table partner if you want to verify first. So again, take a few minutes, answer the 2 warm-up questions, and I will go over answers. All right, so you should have had that you have 26 options for the first letter, 26 for the next, and then you have 3 digits, so that's 10 cubed. So it comes out to be 676,000 options. Whew, craziness. So then it says there are 5 different burgers and 8 different milkshakes on a menu. How many ways can you order 1 burger and 1 milkshake? So order does not matter here, so this is going to be a combination. So you have 5 choose 1. Sorry, that was the bell. And then you have to multiply because it says and, right? And then there are 8 different milkshakes, so you're doing 8 choose 1. So if you multiply that out, you get 40. So what you should probably notice is that 5 choose 1 gives you 5, and 8 choose 1 gives you 8. So you just multiply those 2 numbers. And again, that's because you're dividing out all of those extra options, so you end up with 40. Now, the OR scenario is the one below that, so this would be 5 choose 1 plus 8 choose 1, so then that gives you 13. Because again, that OR means addition. Alrighty, so now we are getting into the rules for probability. We're going to talk about Venn diagrams a little bit more with probability in general, but you should always try to draw a diagram if you're not sure what's going on. The Venn diagram came from John Venn, if you didn't know. He decided this was a thing. Again, back in the day, people had a lot of time on their hands, so they thought about math and life and all that. This is just a quick reminder that the probability of an event has to be between 0 and 1. Okay, if it's a decimal, obviously, if it's a percent, it's 0 and 100. But this is a Venn diagram where you only have one event happening. Okay, so this would be like the blue is the actual event, and then this little AC means the complement, which also means it's the event not happening. So it's either like I run or I don't run, I get an A or I don't get an A, and those are your 2 options. A lot of Venn diagrams have multiple options besides just one. So the probability of everything added together. All right, so just a quick reminder, we've already talked about this, but the probability of all events happening has to add up to 1. Sorry, there goes the bell again. The other thing is the notation for a complement, meaning the event doesn't happen, or like the probability that you're outside of the Venn diagram in that case, is a little c. In a lot of textbooks, you might see something that looks like prime. So that means also, like, that also means complement. But just notice that I've told you guys about this before, but if you find the probability of an event and you want to find the probability of the event not happening, you can just do 1 minus the probability of the event. So we've talked about that a little bit already, but just a reminder. So if they said we opened the last chapter by looking at the traffic light, it says the light is green about 35% of the time. If the probability of the light is green is 35%, it says what's the probability that the light is not green. So I think most of you can probably do this in your head, but it's just 1 minus the probability of it being green. So there's a probability of it not being green by 65%. So again, you're just taking the complement of the scenario and applying it. Alrighty. So disjoint or mutually exclusive would be like I have hair and I don't have hair. So you can't have both things at the same time. So basically mutually exclusive or disjoint. Those are two the same, they have the same meaning. It means that you can't have any overlap. So notice that in your Venn diagram here, you're in two separate little bubbles. So what happens is you could do the probability of A or B happening, and for you to prove that two events are disjoint, if you add them together, it's the same as this is like an OR situation. So whenever you see this, that actually means union, so that's a combination usually. So usually add, okay? But in this case, you can't actually provide any middle part, so you're literally just adding the two events together, okay? Because they're completely independent of each other. So they gave you an example of the addition rule down below. They said, when you get the lighted collagen made, it's either red, green, or yellow. We know the probability of green is 35%. We suppose we find out the probability of yellow is 0.04, or 4%. What's the probability the light is green? Or sorry, light is red. I can't read today. Find the probability that the light is green or yellow. So you can't have both happen, which is why it's not an AND scenario. So you literally just add the probabilities together. You might see that below. And if you hear a little jingling, sorry, it's my stylus that's moving around. So it's a 39% chance of it being green or yellow. So for you to find out whether it's red, you could just do the probability of green or yellow and subtract it from 1, which is what they did down here. So the probability of it being red is the 61%. All right, so now we're talking about things that are not disjoint. So in this case, you can't have these be disjoint unless there's literally no gap. So in this case, they even kind of highlighted it for you, but they're saying that it's not disjoint. A and B, that little symbol is like an and. That's always just your intersection. So basically it's like what they have in common. Intersection. Oh my gosh, this is not working. Okay. Again, that literally just means and the opposite symbol, like from down here, that means or, okay? And again, or means add together. So again, this is what we do when we multiply the probabilities together if they're independent. So in our case, it's the intersection. So if they don't give you the data points, you're just looking at that middle point if they give you a Venn diagram itself, which is a little bit easier to deal with. I skipped a page. Okay. So this chapter actually goes by pretty quick. So it says apply the multiplication rule and others. So again, they're asking you for the multiplication rule if you see what looks like an and symbol. Again, that's not really new to us because we did that in the last chapter. But if they're two independent events and they don't give you a Venn diagram, you can just multiply the probabilities together. Otherwise, you just find the intersection. And then the other scenario was the probability you don't hit a red light until Wednesday. This is the complement scenario, so not red. Oh, my smartboard is freaking out. Hopefully you guys didn't see it just got fuzzy on my screen. So read through all three of these questions and you can see how the answers work. This one is like the bottom one is a little crazy. But it says having a stoplight at the light at least once in 5 days. It's easier to find out the probability of getting it red or no red lights for 5 days in a row and then find the complement. Because this is like that scenario where I asked you to figure out like how many of the siblings were all the same gender. It's easier to find that than having all different genders. So if they asked you for all different genders, you find the complement. And if you don't know what I'm talking about, then we'll talk about it on Wednesday. All right, last scenario. Unfortunately, if I was there, you guys could actually search for the answer. This little black bubble like moved around on my smartboard. So instead, I'm going to have you try the questions that are below, and you will see the answer in a second because I'm literally just going to tell you what the answers are. So try it out. If you want to work with your table partner, if they're in the same spot, you can. But then I will pop up the answers in a few minutes. Alrighty, folks, hopefully you are finished. If you're not, just pause the video until you are done. So number 1, you may have recognized is just literally 0.76 because they gave you that in the question. Number 2 is 0.76 times 0.76. Because it's basically like getting it the first time and the second time, so you have to multiply them. So you end up with about 58%. This was 76%. Okay, number 3 was 1 minus 0.76 squared times 0.76, which gives you about 4%. If you found that another way, you could do that too, but whenever you see the interview's first successful contact is the third household on the list, you basically have to think about your 2 previous scenarios too. So this is like not getting the contact on the first 2 times. So if you listed them all out, that's fine too. You could also just do your 0.24 times 0.24, and it's the same thing. And then number 4 would be, again, this is like kind of the long way to do it, but if you have the same answer, that's good. This is just like a complicated, it's basically like 100% when you get the answer. It's 0.9992, so it's approximately 100%, which is crazy. Which is kind of nice because if they have a 76% success rate, it makes sense that you have at least one successful contact amongst them. Whenever it says at least, that's kind of a hint that you should do the complement, like the 1 minus scenario, but you can always get the answer technically by doing it a little bit harder. It just takes a little bit more time. All right, so I told you guys that when you're done, you can start your homework. I do want you to do one little practice paper, and you can do this with your table partner or by yourself, and I'm going to have you pass it into the sub. So make sure you do that first, and then I posted a link to the textbook, the chapter, so that if you finish the practice as well, you can actually do your homework. Most of you will probably finish both before the end of class. But the paper itself, you should grab from the sub as well and do a little bit of practice with chapter 14. All right, enjoy the rest of your day, and I will see you tomorrow.